Okay, so for this week's project, we're going to fast forward about 4 decades from where we were last week. We're going to take a look at this Harman Kardon AVR1700 home theater receiver. And this unit belongs to an old customer of mine, an old friend of mine from back when I had my shop. Got in touch with me and asked me if I could take a look at this for him. He says the unit will turn on, but immediately it shuts right back off. And the only thing he really knew is that possibly when he was making some speaker connections, he may have shorted the wires, or maybe the problem kind of started around when that was done. So as always, we'll have to open it up and see if we can figure out what's going on. This is 100% modern. This doesn't have a transformer in it. It has a switch mode power supply in it. And from what I can tell by looking through the top, I do see outputs, actual Sanken outputs, so it's probably a class AB. And so it's got that going for it, I guess you would say. But there's a few connections in the back we'll want to take a look at, a few buttons in the front. So as always, we'll come in and have a look at those things. Our intro music this week, we're listening to the Transformation album by Eric Gales. Absolutely one of my favorite albums from back in this time. Basically heard the song by accident. It was a suggestion from one of the streaming services that I use. And I looked up the entire album, listened to the whole thing, and bought the album the very next day. Absolutely amazing workmanship on this record, excellent production of this, everything very, very nice. And of course, this is my favorite song from the record, Time Waits for No One. So let's hear a little bit of this, and then we'll get started on the Harman Kardon.
Quiet little coffee shop. I've been sitting here such a long, long time. I wonder if she blew me off. Looking for the girl of my dreams, tired of getting caught in their schemes. Isn't any right what they see? Time waits for no one.
All right, let's pick back up. We'll have a look at the front of the unit. We got the model kind of branded into the front plastic here, AVR1700. Right below that is going to be your power button. Tuning mode, which I assume is stereo mono. Channel button. There's a digital button here, assuming that's for selection between the digital inputs. Get your directional arrow, a set button, another directional arrow, tuning up and down, and surround mode and surround select. I assume that's what that is, followed by the source up and down. And of course, they're going to give you an infinite volume control. And there is some information that I assume appears in the front display here. You can kind of see that there's a fluorescent tube back in there coming up over the top. I guess this is as good a place as any to start. Switch mode power supply looking more like this is a computer than an audio receiver. And they've taken caution to thermally protect these devices. This is probably the MOSFET in the front side, primary side of this. And so they want to make sure that this thing goes crazy and starts heating up, that it shuts everything down. They did another one in the back primary or secondary side on one of these ICs. As for the capacitors in this, they look Nichicon, but they're not. They are Sam Young, whatever that is. It doesn't ring a bell with me. And the other brand is what? Acon? Not so sure I know those either. Yeah, I don't know. Top mounted HDMI, Ethernet, digital board, basically all signals passing through this thing process right here. And so this is kind of the hub of the whole deal. There's an AM/FM tuner right there. And that's mounted on the small board that contains the analog jacks and the composite video, which I'm not even sure why they even include that anymore. Not much to speak for filter caps in the audio section. And it does have SANCON outputs in it. These are probably the same ones I pulled out of a Pioneer digital receiver not too long ago. Can't really see the numbers. We'll be able to more if we have to go to that area. Flipping it around, let's take a look at the back. Of course, you're going to get a hardline Ethernet connection, and this one's giving you 6 HDMI inputs. And this one even has, for the output, it has an audio return channel, so if you're using the TV tuner, it'll shoot the audio back so you can hear it through this surround sound receiver. Connections for the antennas. And then they're going to give you a few analog things here. Analog audio in 1 and 2. And in and out. IR in if you've got a control system using that. And a trigger out if you want to use it to switch on your projector. Here's your digital inputs, 2 opticals and a coaxial. And then just simply 5 outputs for your speakers, right, left, what is that? Surround right, surround left, and center. And then again, we've got some composite inputs here. I don't know if this is a unit that will upconvert that composite into an HDMI or not. Maybe we can find that out. And then RS-232, if you happen to have a control system that uses that, you can get yourself going through that. Master power switch in the back and an ungrounded outlet. And a preamp out for the sub, of course. So I don't know. I guess the first thing, let's go ahead and hook it up and see if we can duplicate what he's saying. He says it'll turn on and turn right back off. So give me a second for that and we'll come back. And got power connected to the unit. And when you hit the power button, this is what we get. Get an immediate white and then right off, just like he said it was doing. And then it goes into a blinking pattern here, but it doesn't stop, it just keeps blinking. I would imagine that in the service manual for this probably refers to this as some type of error or code. Now I did notice this. We've got plus and minus 45 coming out of that switch mode power supply, feeding right over in to the amplifier board. So what I'm going to say is let's go ahead and we'll kill the power. That should die off. There we go. And let's pull that plug out of there. Okay. And now let's go ahead and we'll hook it back up. And look at that. Comes up, stays on. Let's see what we get here by 5-channel stereo, and this is the source. TV, audio, HDMI, cycles to all of that. I don't know what this is all about. Yeah, I'm not sure what that's all about. Home network. Probably can pull files maybe from your computer, music files from your computer if it's on your network, I assume. iPod unplugged, USB unplugged. So let's do this. We know it'll stay on, but let's make sure we got video coming out of the HDMI board. Let's go up here to our monitor. Turn that on. Let's plug that in. We'll switch this. I don't know what's going on. There we go. And it shows the frequency, so we know we're outputting video. So it shows the volume. So we're definitely on the right track. I think the next step, let's go ahead and we'll run the outputs real quick and see what we can spot as far as a short. I would assume to shut the whole thing down, there's probably a pair of outputs shorted. And he did refer to maybe crossing the speaker lines or shorting the speaker lines out, so that would all kind of jive. So give me a second, we'll put the camera on the magnifier overhead and we'll run the outputs real quick. All right, let's run these and see if we can come up with what might be causing the thing to shut off here. And the way they got these paired up is they got two right together, but those are not the actual pair. The pair are here and here. I think they just have them arranged kind of weird. No trouble. No trouble there. Let's move this little cable out of our way. Maybe. Rolling a 0 here. There it is right there. Right there. So this one would be this one's mate. So let's see if the other one is shorted. Well, the other one doesn't appear to have a short in it, but this one damn sure has a short in it. All right, so I think what we're going to do here is, obviously we can't work on this until we get some of it apart. So what I found with the ones that don't have, and this is obviously one that does not have any bottom access. So probably what the easiest thing to do is probably to remove the back panel, leaving this board and this board attached to it, and just unplugging cables, and then we'll just kind of move that out of the way, and then we'll remove the amplifier board completely out of the unit. So give me a second for that, and I'll go ahead and start taking this apart. All right, coming back in, went ahead and pulled the back panel of the unit off, keeping the HDMI board and the analog board still attached to this, and 3 screws later and the whole thing comes off. And that gives us access to remove this board from the bottom of the chassis. 3 screws down in the heatsink and 3 on the main board, and the whole thing comes right out, giving us really easy access to work on it. Now there is a pair here that we're having trouble with, and from what we could tell before we pulled it out, just the one was shorted, not the other one. So we're going to definitely confirm that and then check through some of the supporting circuitry. But it'll be much easier to work on down here on the bench versus trying to do it through all of this. So let me go ahead and I'll put the camera on the magnifier overhead, and we'll confirm that the other transistor is not shorted, and we'll check through some of the supporting circuitry and see what we can find out. So give me a second for that and we'll come right back. All right, we pick back up. Again, this is the area we're working in right here, and this is the one that we confirmed is definitely bad. There's a emitter collector short, but this is its partner, and there is no issue here whatsoever. We'll make a side-by-side comparison to another 2SD 2390, 2SD 2390. I'm going to compare this one. And it is dead on with the one that's over here. So let's take a look at our, looks like 0.47 emitter resistors. Well, that is definitely an issue. That's fine. I'm going to switch this over to ohms just to take a look. There is no problem at all with that. But that is definitely the two that correspond to the 2SD or 2SB 1560. Those are open. Not sure if I can get this in the shot or not. Probably not, but we'll try. I don't think so. I don't think so. Yeah, maybe. I can get it in the shot, you just won't be able to see it very good. There we go. Switch it to ohms. And of course, right here, 0.004, 0.004, but over here, going off of the rails. So they are definitely bad. So when that shorted, it just took these two, opened these two up with it. And so we'll have to get this one out in order to confirm any of the other semiconductors down here have any trouble. They probably don't. It's been my experience with these type of receivers that it usually doesn't do a lot of secondary semiconductor damage. I think it'll be easier if we flip the board over, so let me do that. And I realize that puts kind of a shadow. But we're just going to check through it real quick here, confirming where we're at. And that's our shorted section right here. So we're going to follow that up into this little area. Keep letting my probe hit right there. And if I get a reading that's a little wonky, what I'll do is we'll just move over to a channel that's good and confirm it with a good channel. And it's totally fine, so I think we're okay. I don't see no trouble there, so I think let's pull that back some. All right, so I think what we're going to do is this. I'm going to show you this. Oh. Not too long ago, I tore down a Pioneer home theater receiver that's not too far off from this 2012 model, and I pulled this board out of it. Now, the problem with the Pioneer is that the digital board or the HDMI board was bad. There was nothing wrong with the amplifier. So I pulled out the supporting circuitry or driver board from that unit, and I also pulled out the outputs. And as it turns out, they're a dead-on match. 2SD2390, 2SB1560 Sanken outputs, and these are original. These are not knockoffs. And this is set up very similar to the Harman Kardon. I mean, these are all laid out very similar nowadays because of the way that they design it. Right down to the emitter resistors. These are 0.47 that's in here. And so we're going to, normally what I would do is I would pull out the bad ones and fire it back up and see if it comes up and it works. I'm not going to do that this time. We're going to go ahead and pull these out, the bad ones out. We're going to replace them with a pair from the Pioneer and with the two emitter resistors that are open, and we'll bring it up, fire it up, and see if it works. Yeah, there isn't any need, since this is such a level of difficulty to take it all apart and put it back together again to try it. We're not going to mess with that. We're going to skip that step. We're going to go ahead and put the parts in, and then from that point, we'll find out what we got. Now, we only have one transistor that's shorted, but I am going to change them as a pair. I'm not going to just change the one that's shorted. I'm going to change them as a pair. So give me a second for that, and we'll come back, and we'll get these out, and we'll get the replacements put in. All right, we'll come back in. We'll go ahead and get these two guys out. I went ahead and desoldered them from the bottom, so we don't have to deal with that. Didn't desolder the emitters, though, so we'll have to go back and do that. But these should come out fairly easy, leaving the insulator right on the heatsink. That's the way we want to do it. And that is our 2SB 1560. We'll use the replacement one we took out of the Pioneer. We're going to add just a dab of heat shrink or heat sink compound to that. Don't have to go nuts. This is the one right here. These barely even come with any heat sink compound from the factory anymore. They used to overdo it, and in recent times they've kind of gotten away from overdoing it and just minimal amount, basically. Try to find the sweet spot for that screw. It's got a washer on it, and I'm turning the washer more than I'm turning the screw. I'm not going to crank it down. I'm just going to snug it up, and after I get it soldered in, then we'll give it a final tightening. I want to be able, I can still move it, because when we get underneath, we'll have to reposition it anyway. Now we'll take out the 2SD 2390. Again, this one not shorted, but there's just something about changing only one and not a pair that seems a little bothersome to me, but probably could have gotten away with it. But then I would have had an odd one from the ones that I pulled out of the Pioneer, so I think I'm fine with changing them both at the same time. By far, these type of receivers, usually you will experience a digital board failure way long before you would have an amplifier issue, unless you did something you weren't supposed to do, like in this particular case. If you did accidentally short the speaker wires, it's probably what created the issue. All right, let's flip it over. See what we can see here. Now let's turn it around like this. There we go. And this is where they come in, and we're going to do exactly what they did, and all they did was just bend the pins over. And so that's exactly what we're going to do. And we'll solder them up. Looks pretty good. I'm going to reconfirm the two emitters and we'll get those out. Those are the good ones. These two are the bad ones. Use a little solder wick and we should be able to get them out fairly easily. Sometimes it does help to add a little solder to it. They're so thin. The layer of solder they put there is just so small. It's hard to get the solder wick to suck into it. Should do it. All right, I'm going to pull those out real quick. And we're going to clean the board up. It's the only real huge downside. The solder wick does leave behind quite a bit of residue, so you don't have to do this. It's just a step that I always do. Okay. And I did pull this out too from the Pioneer board. And of course, 0.47, just like we got right here, exactly, almost exact same thing. And we were talking earlier in the first part of the video about those, what was it, Sam Young caps? And sure enough, in this board, there is Sam Young caps. Let me find the name on one of these. I'll show it to you. Young Sam or Sam Young? Yeah, Sam Young, I guess, not Young Sam. Guess they must have got a deal on them. Now hopefully those will stay in place long enough for us to flip it over and get them soldered in. think we're going to be okay. And that should do it. Unless there's something that I'm not spotting. We'll check these against the other ones. Put this on ohms. These say 0.5, 0.4, it's toggling, 0.4 to 0.5. Definitely well within tolerance. Yeah, these are okay. So I think we're good there. All right. So basically all that's left is reassembling the whole thing again. So I'm going to go ahead and do that. First I'm going to tighten these up just to make sure that I'll go through and tighten them all up just to make sure they're all snugged pretty good. And then I'll go ahead and get the board put back in, and we'll bring it up and we'll see. Don't see anything else. Checked through everything after I had the outputs out of it, and it was working fine, or it was looking fine, I should say. Everything was testing fine, so if there's anything else going on, I'm certainly not aware of it. It'll be a surprise. So let me go ahead and get it all put back together, and we'll pick back up. All right, and this is from the Pioneer board. And it was Sam Young I was trying to think of. Not Young Sam, but this board is full of those caps. So that must be a new thing or a thing back in 2012 or in and around that time. Not Samsung, but Sam Young. Interesting. Got it all put back together, plugged in, and fired right up. No trouble whatsoever. And we're running this just on the center channel. In case I didn't mention it while we were working on it, that is the one that was damaged. And so just dumped a signal into one of our analog inputs. And just our center channel for now. We're going to run this for a while. Get it a little warm. And then we'll compare one of the good channels to see what the idle current is running at, and then we'll make the adjustment to this one. They give us some nice little plug slots there that we can use to do a reading, and then of course there's a pot for each one. Make your adjustment. And I don't know, these sometimes run low, like 3, 5 millivolts, somewhere in there, but it's working okay. Starting to heat up a little bit, not too bad. Seems a little warmer over here than it is in the area we worked in. Not too much in the way of on-screen display for this. I mean, there's no menu button on the front, but I assume that probably there is some assignable options in this. But when we hit channel here, this will give us a option to adjust our channel level up and down. I think that's done right through here. There's center. Oh, wait a minute. And then the adjustment's done here, I guess. All right, I'll burn this up a little bit and then we'll pick back up. We'll have a look at the idle current. All right, so we're gonna pick back up. It's been baking up pretty good for about 20 minutes and it's not even really excessively warm. It's just lukewarm and we have no idea what the idle current of this thing runs. And so we're gonna make a comparison against the one of the channels, or probably we'll look at all of them to get an idea of what the channel we worked on should be set at. I didn't bother looking to see if there's a manual online for this. There probably isn't, but even if there was, it's not really necessary to do that. We can just make a comparison from one of the other channels to get an idea of what we need to set the one we worked on at. So let's go ahead and we'll make the check. This is going to be probably the front channel, front right or front left, 21.6, and this is going to be the channel we worked on. $15.3, and we'll look at the one right next to it. And we can see that's 22.7. And then we'll take a look at one further down the line here. And we can see that one's 22.9. So it looks like the going rate of these channels is around 21, 22. That one's 21. So if I had to guess, I'd say it's supposed to be 22. I think that's a pretty good average of what we're seeing here. And so let's try to see if we can set that one at 22, the one that we worked on. And this can be a little tricky. So I'm going to try to hold these and at the same time tweak it. And it is touchy, as you might imagine. And I think we're going to let it go at that. Again, on an average of them, it seemed like 22 is about the going rate. 21.4 there. $22.2 on the one we just did. Probably not a bad idea to recheck after a while. 22.8 on the one right next to it. So I don't know. I'll probably leave it alone. I don't think there's any doubt that we got it fixed. So now it's just, you know, trying to dial it in and get it in the ballpark. I'm sure that service manual would tell you not only the value you need to set it at, but also a plus or minus margin of error of probably about 3 or 4 points. So I think we're good. We'll run it for a little bit longer, and then we'll come back and we'll do a final play test. All right. I want to thank you guys very much for checking out the video for the Harman Kardon AVR1700. It's been an interesting one. Completely opposite side of the spectrum versus last week. Something extremely old, and now we've got something that's coming a little bit more into modern times, even though this one is about, what, 8 years old now. So if you happen to have one of these and you turn it on and it shuts right back off, it could be as simple as a pair of blown outputs, and easy enough to get it apart and to work on it. So on our way out, let's hear a little bit of another very underrated guitar player. This is Andy Timmons. This is his song, Cry for You. Let's check a little bit of this out on the way out.